Hello all, welcome to Agile Digest, and today we will talk about one of the most popular terms in Agile world you might have heard about, called technical depth. Technical depth is something that every Agile teams or the Scrum team, or even if you're working on software development, this is something you cannot avoid. It's like if you are playing, you will get hurt. Only thing that we need to remember that how to manage those pain points, or the you got scratch on your knees, we should not be ignored them. How we can manage them to repair for a long-term development areas. That's our key goal is. So let's try to understand what we will be talking about. Our first topic, understanding technical depths, where we'll be covering define technical depth and its various forms like coding, architecture, documentations, and we'll discuss how technical depth occurs in Agile project in this introduction section. So if I want to introduce, technical depth is a metaphor equating the trade-off between the short-term benefits of rapid delivery and the long-term cost incurred due to not implementing the best overall solution. Just like financial debt, technical debt accumulates interest, making future changes more costly and time consuming. So technical debt is not always bad. It becomes problematic when ignored or accumulated without a plan for repayment. So welcome to our exploration of technical debt, a crucial concept in software development that balances the immediate benefits of rapid delivery against the long-term cost of not implementing the best overall solution. Like financial debt, technical debt accumulates interest, making future changes more costly. However, not all debts are bad. It is the management and repayment plan that counts. So what are the different forms of technical debts? Cause of technical debts we'll talk about in these slides, or what are the different forms, what are the consequences, and how we can manage those technical debt. So when we talk about cause of technical debt can arise from various sources: rushing to meet deadlines at the expense of quality, or gaps in team knowledge, or the evaluation of project requirements and the relentless pace of technological advancement. So understanding these causes help us mitigate the risk associated with acquiring technical debts. So if you are doing the development rush, choosing speed over quality to meet deadlines, or lack of knowledge, so implementing solution without fully understanding the problem or the technology involved, evaluations of project requirement, changing requirement during the development process without refactoring the existing solutions can another cause of technical debt. Technological advancement. Older technology become obsolete as new technologies emerges. So these are very common reason why technical debt may come up, but these are not limited to only these. There can be many other, but these are the common causes that we are talking about. And when technical debt comes, how it comes as a form of technical debt that manifests in many different ways. Sometimes we may talk about code debts, right? Issues with the code base, such as duplicate code, long methods, and magic numbers that make maintenance and update difficult. For example, lack of comments, or poor variable naming, or not adhering to coding standards. Similarly, another form can become as an architectural debts, flaws in the system architecture that hinder its ability to meet current or future requirement efficiently. For example, over-engineering or under-engineering, and improper use of design patterns. These are different forms. So what is the consequences? The next one is documentation depth. So what is documentations? Inadequate and outdated documentation that leads to misunderstanding and inefficiencies in the development process, like missing or incomplete or outdated project documentation, API guidelines, or inline code comments. These can be create a documentation depth. There can be many more, but I'm just talking about these are the commonly visible depths that a team faces when you are working on agile way of working. As a result, what will happen? Increased maintenance cost. More time and resources are needed, and few features or bug fixes will be taken place. Reduce code quality, which leads to fragile code base that is difficult to understand and modify. And decrease productivity. Developers spend more time understanding the code than adding values. And potentials or system failure. High depth can lead to system outage and failures, impacting business operations. So the consequences of ignoring technical depths are very severe, ranging from increased maintenance costs, reduced code quality, to decreased productivity and potential system failure. These challenges underscore the importance of proactive depth management to maintain project health and sustainability. And then how you will be managing your technical depths. First, awareness. Recognize and track technical depth as a part of the development process. Then prioritization. Assess and prioritize the depth repayment based on its impact on the project. Then refactoring. Regularly allocate time for refactoring and improving the code base. And documentation. Keep documentations updated to minimize your technical depth. Effectively managing technical depth requires a strategic approach. It begins with awareness and acknowledgement of the depth with your projects, and then prioritizing repayment based on impact. And regularly allocate time or for your refactoring or any technical depths resolutions, and maintaining up-to-date documentations. Those are the key strategies for keeping your technical depth under control and ensuring the long-term success of your project. So let's quickly talk about how a technical depth occurs in agile projects. So what we'll be covering in this particular area: the impact of technical depth on agile teams, identifying technical depth in agile environment, strategies for managing technical depth in agile projects, and embracing technical depth as an agile opportunity. In agile project, where the emphasis is on the speed and adaptability, and technical depth can inadvertently accumulate as a byproduct of iterative development. So understanding how this happens with the agile framework is crucial for teams aiming to maintain a high quality outputs without compromising future project velocity. So let's quickly look into the impact. It's reduce your velocity. So a depth accumulates. Whenever a depth accumulates, the team's ability to deliver new features quickly goes down. Then it's lowered your quality. The focus on delivery or the speed of delivery over quality can lead to decrease in product quality, and it increases stress. Team may experience stress and reduce morale as they navigate a complex code base. So acquiring technical depth significantly impacts your agile teams, primarily by reducing their velocity. And as the depth grows, more time is required to navigate the code base and implement new features or adapt to changing requirements, ultimately slowing down progress and reducing the team's capacity to deliver value. So how will be identifying technical depth in agile environment? Few practices that you can follow. Regular code reviews. So encourage frequent reviews to catch and address that depth early. Early identification of technical depth is very crucial. Regular code reviews or refactoring sessions which integrate refactoring into the sprint to improve and optimize the code base. And then effective documentations which maintain up-to-date documentations to reduce knowledge depth. So this proactive approach ensures that agility is maintained without sacrificing code quality. Let's talk about what are the strategies for managing technical depth in agile project. There are 4, as you can see: incorporating refactoring, automated testing, continuous integrations, and pair programming. So Incorporate refactoring, where you will be make refactoring a part of the development cycle, not an afterthought. Automated testings. Use automated tests to ensure new changes do not introduce additional depth. Continuous integrations. Implement CI to catch. CI is continuous integration to catch and fix issues early, preventing depth accumulations. And pair programming as a practice. Most of them are part of engineering practices. If you already aware of engineering practices, there are many other engineering practices, but these are the engineering practices which can directly reduce your technical depth if you practice these 4 areas. So pair programming, encourage pair programming to share knowledge and reduce the introductions of new depth. So these, I am not going through much details about these. Maybe I will be covering dedicated video for each of them later on. So the goal over here is managing technical depth in Agile project involves a blend of these strategies. Refactoring should be part of the regular development cycle, and automated testing and continuous integration can prevent the accumulations of new depth. And practices like pair programming, which encourage knowledge sharing and reduce the likelihood of introducing new depth. So by integrating these strategies into Agile workflows, teams can maintain their pace and quality, ensuring sustainable project development. So let's talk about how technical depth occurs in Agile project, embracing technical depth as an Agile opportunity. Continuous improvement. So use the identifications and repayment of technical depth as an opportunities for improving process and code base. Rather than viewing technical depth as purely negative aspect, Agile teams can embrace it as an opportunity for continuous improvement and innovations. Addressing technical depth can lead to innovative solutions and better practices, and bring up the team growth as well. Working together to manage technical depth can strengthen team collaborations and their expertise. By strategically addressing this technical depth, teams can refine their process, improve their code base, and enhance their adaptability, and turning potential setbacks into a catalyst for growth and development. So impact of technical depths. What we will be covering in this area is project health deteriorations, compromise product quality, team morale and productivity, barriers of innovations, long-term strategic impacts, and managing the impact. So let's make a deep dive into the impact of this technical depth, where we uncover how the accumulations of shortcuts and compromise in software development can lead to significant challenges for both project health and team morale. Let's talk about what's the impact of technical depth. We'll first start with the project health degradations. Increased maintenance cost. Technical depth leads to higher cost for maintaining and updating the project. Reduced flexibility. Accumulated depth makes it difficult to adapt the project to new requirements to technologies. And delayed delivery. Depth can cause delays in feature delivery and project timelines. So technical depth acts as a hidden tax on your project, leading to increased maintenance cost or reduced flexibility and delayed delivery, like a plant struggling to thrive. A project burdened by depth can reach its full potential, stifling growth and progress. Compromise product quality. Your bug or count of bugs will be increased. So technical depth can lead to more bugs and stability issues in the software. User experience will go down. The impact of the technical depth on the user experience, including performance issues and usability problems. Security vulnerabilities. Neglected code and outdated practices can lead to security risk. So as your technical depth grows, accumulates, product quality will suffer and bugs become more frequent. User experience will go down and security vulnerabilities will be emerges. This is a key into a well-oiled machine turning into a rusted relic, struggling to perform its intended functionalities. Team morale and productivity. Increased stress, Dealing with a complex and depth-ridden code base can increase stress levels among team members, reduce productivity. Teams spent on navigating and fixing issues related to technical depth that detracts from the time that could be used for new features or improvements. Burnout and turnover. So, risk to burnout and increased turnover as team members become frustrated with persistent issues. So, the weight of technical debt does not just slow down projects, it also dampens team spirit, increase stress, and reduce productivity. And the risk of burnout can transform a one vibrant team into a group struggling to keep pace, undermining motivations and efficiencies. Let's talk about the next one, how it can become a barriers to innovations. Innovation always got shifted. Accumulated technical debt can stifle innovations by consuming resources and energy that could be spent on new ideas. Technical stagnations. A focus on repaying debt can prevent the adoptions of new and better technologies or practices. So this can become a barrier of innovations. So technical debt that erects barriers to innovation, consuming the resource and energy needed for new ideas and improvement. And this wall of debt prevents the tree of innovations from reaching the sunlight, right? Stifling growth and advancement. And then we will talk about long-term strategic impacts, which increase maintenance costs. Technical debt leads to higher cost of maintaining and updating the project. Reduce flexibility and accumulated debt makes it difficult to adapt the projects to new requirements of technology. Delayed delivery. Debt can cause delays in feature delivery and project timelines. In the race of these market leaderships, technical debt acts as a heavy weight that drags down your project, affecting customer satisfaction and your ability to compete with your competitors. As your project slows down, competitors race ahead and capitalizing on your inability to adapt and innovate. Let's talk about the next area where we'll talk about how we can identify and measuring technical depth. Technical depth is something that you cannot avoid. Every project there will be technical depth. So to manage or to get rid or to balance that out, first thing we need to identify and measure. Then you will be able to take action. So what we'll be learning from here in this particular chapter is the challenge of identifying the technical depths, key indicators of technical depth, tools and techniques for measuring technical depth, the role of automated testing in technical depth, then incorporating depth identifications into agile ceremonies or events, strategies for prioritizing technical depth repayment, and balancing new features and depth repayment. First, we will be talking about what are the challenges of identifying technical depth. The typical challenge every organizations they face. Technical depth is often concealed with the complexities of project development. And identifying depth requires a deep understanding of the code base and its architecture. Tools and practices are essential but not always sufficient to reveal all depths. And commitment to regular review and assessment is key to uncovering hidden depth. We'll talk about that how you can navigate the signals, the key indicators. How do you know there are possibilities of technical depths? You may realize there are code complexities. High complex levels in code may signal a deep-seated technical depth. Bug rate, an increasing trend in bug rates often points an underlying issue. Or code duplications, repeated code blocks across the project indicates inefficient coding practices. Documentation gaps, lack of up-to-date documentations that hampers understanding and increased depth. So these are not all the possible signals. I'm just highlighting a couple of signals that you may already have observed. But those are the patterns of different challenges that you may face, which may because of some technical depths are rising up in the behind of the scene. So what tools and techniques you can use to measure the technical depth? Static code analysis. So automated tools that scan code for complexity and style violations and potential bugs. You can capture the code review feedback, insights from the peer review that highlight areas needing improvements or refactoring. Technical depth quadrants, categorizing technical depths into intentional versus unintentional and reckless versus prudent to prioritize actions. And depth metrics, quantitative measures such as rework time or code churn to estimate the cost of depth repayment. There will be many other techniques or tools, and the tools that I also have mentioned over here, I'm not going into very deep dive into it. If you think there is some areas you will be interested in, let me know in the comment sections over here, and I will be try to add few more details on those area if I see there is a need of. The point over here is, for example, this is a technical depth quadrant. So there is a tools that you can use, a practice that you can use to create 4 quadrants and find out where are the technical depths maybe resides into. Let's talk about the role of automated testing in identifying depth. Though I will be talking about the role of automated testing in little more details, but over here I am just highlighting in upcoming couple of chapters I will be talking in more little more details. Your automation testing help you detect early. So automate test help identify problematic code early in the development cycle, preventing the accumulations of the technical debt. Continuous integrations, that integrating automated testings into continuous integration pipelines that ensure consistent code quality and highlights areas needing refactoring. Quality assurance, beyond finding bugs, automated test assess code maintainability, readability, and adherence to best practices. Feedback loop, which provides immediate feedback to developers, allowing for quick adjustment and minimize the introductions of new depth. Let's talk about identifying and measuring the technical depth in incorporating depth identification into agile events or ceremonies. So sprint planning, dedicated time to prioritize and plan for technical depth reduction that task alongside new feature development. Daily stand-up, regularly discuss progress and challenge related to the technical depth task to maintain visibility and momentum. So don't just focus into only the features or stories that you are working on, because technical depth, if you have planned, you will be planning, because based on what I will be talking about, how you can take some slice of technical depth at every sprint, you will see that there are some technical depth resolutions or that you will be resolving in the sprint is a part of the scope of the sprint, and you should give the equal importance to the technical depth along with the feature development. When you are doing retrospective, reflect on the accumulation of technical depth in the previous sprint and strategize improvement for the next cycle. Backlog refinement or grooming, continuously identify and assess technical depth items in the backlog, ensuring they are accurately estimated and prioritized, and those are given enough value. Let's talk about something, balancing new features and depth repayment. This is very important. When you are working on a sprint, you need to make allocations, a balance between what are the different nature of work that you need to do apart from user stories. So that is the strategy for every teams who wants to control the technical depths allocation, technical depths piling up. You need to manage that. So strategic allocation, where you prioritize tasks by balancing the development of new features with the repayment of technical debt to maintain project momentum and ensure long-term sustainability. Iterative approach, implement an iterative approach or small time boxes to balance between adding new functionalities and addressing technical depth in each sprint or each iterations. Stakeholders engagement. We'll talk about the role of stakeholders engagement in more little details, where you regularly communicate with stakeholders about the importance of technical depth reductions to secure their support and understanding, for dedicating resource to both new features and depth repayment. And continuously monitor it. Establish a system for continuously monitoring the impact of technical depth on project timelines and quality, allowing for real-time adjustment to the balance between innovations and maintenance. So, in the ever evolving landscape of software development, striking the right balance between forging new paths with innovation and maintaining the ground beneath your feet is paramount. This delicate equilibrium between introducing new features and repaying the technical debt is not just a matter of scheduling but a strategic approach to sustainable project growth. So, by integrating an iterative approach, we ensure that each sprint contributes to both our immediate goals and our long-term visions. Engaging stakeholders in this process is very crucial. The balance that continuous monitoring acts as our compass and guiding adjustment and ensuring there are neither innovation nor maintenance overwhelm with each other. So through this balance approach, we achieve a harmony that propels our project forwards, ensuring that they are not only meet the demands of the present but also robust and adaptable for the future. Let's talk about how are the strategy for prioritizing technical debt repayment. Though you will be able to get with the how the data is flowing through an example that I'll be talking about kind of end of this slide. Impact analysis. Evaluate the impact of technical depth items on project functionality and team productivity to prioritize tasks that will deliver the most significant benefits. Risk assessment. Consider the risk associated with each depth item. Focus on those that pose the greatest threat to system stability and security. Business goals alignments that align debt repayment efforts with current business goals and objectives, ensuring that prioritization reflects both technical and business priorities. And effort versus reward. Analyze the effort required to repayment versus the potential reward or targeting depth that offers substantial improvement with the manageable effort. So whenever you do a software development, you form an ecosystem, and in that complex ecosystem, technical debt can often seems like a challenge. So with strategic prioritizations, it becomes a manageable and even empowering aspect of project management. So you can conduct thorough impact analysis and uncover which aspects of technical debt hinders your project functionality or your team's productivity. The most you identify, you do a risk assessment after that, which further refines your focus, allowing you to address depth that threatens your system stability and security before it becomes a critical issue. Right? Alright, so let's move to our next area where we'll talk about little deep dive into the strategies of managing and reducing technical debts. So what we will be doing, the key steps: recognizing the need of technical debt management, refactoring as a core strategy, the role of code reviews. So refactoring and code reviews, there are few engineering practices though, for example, pair programming, continuous integration, those are all factors that can reduce down your technical debts. How you can bring up the automated testings, how you can apply continuous integrations to bring your technical debts low. So balancing feature development and depth reductions and engaging stakeholders in depth management, creating a culture of continuous improvement. Let's talk about the first one, how we can recognize the need of technical depth management. Right? Awareness. Cultivate an environment where technical depth is acknowledged, and that acknowledgement should be a natural byproduct of software development. We understand that they should acknowledge, okay, this is something that will happen, we cannot avoid it. You should emphasize the importance of awareness across the team. Then you need to bring up the visibility, implement tools or practices to make your technical depth visible, make it transparent. That's one of the key pillars of your empirical process, transparency, make it visible to everyone. Ensuring it is not just recognizing but actively monitored. You take the approach proactive, encourage a shift from reactive to proactive management. Don't just put your technical depths in a backlog and says we will take care of that later. Try to work on a proactive nature. One area, kill the technical depth as soon as it is coming and try to reduce to go high. Right? So recognize that early identifications and interventions prevent depth from becoming unmanageable. And you need to bring up a continuous education. Foster continuous learning within the team about the implementations of technical depth and the benefits of its management to maintain high quality standard. So by making the depth visible through targeted tools and practices, we empower all stakeholders to take part in its management, transitioning from a culture of reactivity to one of the proactive engagement. So if I look into the refactoring, what is refactoring and how it's help our technical depth reductions. Refactoring is a disciplined process of improving the internal structure of code without altering the external behavior, aimed at enhance understanding, maintainability and extensibility. So refactor is one of the best practices when you are working on Agile. I'm not going into very deep dive into refactoring in this video. Maybe I will be creating something later on. But for your understanding, think about that we have created a login page and the password the user is entering, we are saving as it is in the database. And during the audit, we find out, okay, we need to save the password, or even a credit card information is an encrypted form. So we will be doing, that's a technical depth, right? It's not a good secure way you are saving the data. So this refactoring, you may spend some time to refactor all these kind of issues to encrypt the data, password data, and decrypt it when you are reading. It's not changing the external behavior to your user, but it's actually changing your code maintainability or security of your code. Similarly, you can apply that one of the report is taking 3 seconds because the stored procedures was created too many nesting queries. So we can do some refactoring to optimize that stored procedure or to optimize that query so that it can load in 1 second. Ultimately, the result is not changed, but the performance maybe came down. There are many encryption logic created by different teams, but we want a central library. So that is also encryption refactoring where the result is not there. So that helps technical depth reductions. Technical depth reductions, refactoring is directly address technical depth by identifying and rectifying code smells, reducing complexity and eliminating redundant or obstacle code, thereby preventing the accumulations of future depth. What's the benefits of refactoring? Improved code quality leads to cleaner, more efficient code that is easier to understand, test and debug. Increased maintainability simplifies the code base, making future challenges and additions more straightforward and less time consuming. Risk mitigation. By continuously improving code structure, refactoring minimizes the risk of introducing new bugs during enhancement or bug fixes. So refactoring should be the strategy. So imagine if with a few strategic adjustment, we could transform a tangled web of code into a masterpiece of clarity and efficiency. This is the essence of refactoring, a meticulous process that enhances the heart of our software without altering its pulse. Refactoring is our most reliable ally in the battle against technical depth, and it empowers to proactively improve code quality, turning potential liabilities into a robust asset that stands the test of time. Let's quickly look into the next area where we'll talk about what is the role of code review. Number 1, preventions of new depth. So code review acts as a critical checkpoint in the development process where peers scrutinize new code for potential issue. Without integrating, the practice helps in catching bugs, identifying optimization opportunities and ensuring adherence to the code standards, thereby preventing the accumulations of new technical depths. Number 2, identification of existing depth. Through the collaborative examinations of code, reviewers can identify and highlight areas of existing technical debt, such as complex code blocks in need of refactoring, or duplicate code or outdated comments that no longer reflect the code's current state. Number 3, collaborative nature. Code reviews foster a culture of knowledge sharing and collective accountability. Encourage all team members to contribute to and take part in maintaining code quality. This collaborative approach enhances team engagement, spread best practices, and reinforce shared responsibility for the project's technical health. So what's the benefit? If I look into the benefit, number 1, enhance code quality through code reviews. Regular code reviews elevate the overall quality of the code base, making it more maintainable and less prone to errors. Team skill development. So participating in code reviews educates developers about common pitfalls and effective coding techniques, improving individuals and team competencies. And increase project visibility. Engaging quality team members in the review process increase project awareness and understanding, promoting a more cohesive development efforts. So how automated testing and continuous integrations help reducing or managing your technical debt? Let's talk about automated testing. Automated tests serve as an early warning system in the software development lifecycle, systematically identifying errors, bugs, and vulnerabilities before they evolve into significant technical debt. By covering various levels of testing, you can go for unit testing, you can go for integration testing, you can go for system testing, and these automated tests ensure that each component functions as expected, reducing the likelihood of costly reworks and ensuring high quality outputs from the start. And the second, we have CI or continuous integrations. That practices amplify the benefits of automated testing by integrating code changes into a shared repository frequently. And this process encourages small, manageable updates that are automatically built and tested, highlighting integration issues and regression errors early. And CI practices not only streamline development workflows but also maintain code health by ensuring that new changes do not adversely affect the existing system. So what are the benefits? Early detection. Facilitates the early detections of issues, allowing for quicker fixes with less impact on the project timeline. Code quality assurance. So provide a consistent mechanism for quality assurance, ensuring that all code meets predefined standards before integration. Reductions of technical debt accumulation. So by catching and addressing the issues early, automated test and CI practices significantly reduce the risk of technical debt accumulation, keeping the code base clean and maintainable. And enhance team productivity. Streamlines the development process, enabling teams to focus on delivering new features and improvements without being bogged down by technical issues. The software development nowadays going very fast, right? And maintaining the health of our code is in this situation is paramount. Automated test and continuous integration stand as a twin pillars, supporting our endeavors to keep technical debt at bay. Automated tests, with their relentless vigilance, uncover errors and inconsistencies at the earlier stage, acting as our first line of defense against the erosion of code quality. When paired with the disciplined rhythm of continuous integration, these tests go beyond mere detections, weaving a safety net that catches potential issues as we weave the fabric of our project. So this harmonious blend of automations and integration does more than just safeguard our code, it elevates our practice of software development. It ensures that our journey toward is not hindered by unseen obstacles, allowing our team to advance with confidence and creativity by embedding automated test and CI into the heart of our process. We commit to a future where excellence is the standard and technical depth is the exception. Let's quickly go into the next, where balancing feature development and depth reduction. So emphasize the crucial role of strategic planning in balancing the dual objectives of introducing new features and reducing technical debt. This balance is essential for sustaining long-term project health, ensuring both innovation and stability. So, allocating resource and time. We'll quickly look into how it can help, how you can allocate different resource and time. Many organizations, they go for dedicated sprint for depth reductions. Allocate specific sprint, focus solely on understanding technical depth, separate from feature development cycle to ensure concentrated effort on improving code quality. Incorporate depth reductions in regular sprint. This is something we will be exemplifying in our example in later on, where we'll see some data we will be driving from different sprint in our strategic planning after identifying the depths. So this is where you can integrate technical depth reduction task into regular development sprint, dedicating a percentage of each sprint capacity to those tasks to maintain a continuous effort towards depth repayment. Now, if you are working on sprint, maybe you may not need to allocate these particular technical depth slices at the very beginning. Maybe after 4 or 5 sprints, you realize the technical depths are started accumulating. Then you start that allocations. Maybe your target is to reach up to 20% of your capacity. Maybe in the third sprint, you need 5%. Then you increase it to 8% or 10% based on the current number of technical depths, where you will be reducing down the feature development and increasing your allocations of technical depth. And not only the technical depth, there may be many other works. You may think about we will be doing some documentation work. Sometimes documentation is a new documentations, or sometimes documentation as a part of your technical depth, or architecture work or infrastructure work. That capacity allocation is important. If you don't do so for a long period of time, after 10 sprint or 15 sprint, you realize there are so many technical depths. Then you may need to immediately jump into the first point, where you may need to go for 1 or 2 dedicated on 100% technical depth reductions. As we want to deliver some potential product every iterations, we want to make a balance. So act early. Don't wait for the last moment. Then prioritize based on impact. You may have many technical depths, but you need to prioritize them. Otherwise, I cannot handle all of them. Similarly, in your product backlog or your feature backlog, you have huge list of items. You don't work on all of them. Similarly, technical depths, you prioritize which one are showstoppers, right? Use prioritization framework to assess the impact of both new features and technical depth items, and directing resources to areas that offer the highest value or risk mitigations. And there can be another area, stakeholders engagement. We'll talk about stakeholders engagement in little more details. But for now, this is one of the area where you need to involve our stakeholders bandwidth so that they can involve with, understand what is technical depth. Engage stakeholders in the planning process to align expectations and secure buy-in for dedicating resources to technical depth reduction, highlighting the long-term benefits to project health and efficiency. So how we can engage stakeholders in depth management? Highlighting the critical role stakeholders that play in the successful management of technical depth. Their understanding, support and involvement are essential for allocating the necessary resource and prioritizing efforts to address technical depth effectively. So what are the techniques you can follow? Number 1, you may need to have a transparent reporting. Utilize clear non-technical language to report to the state of technical depth, its implications of the project timeline, cost and quality, and the benefits of addressing it. Next, visualize or visualizations and metrics technique that you can follow. Employ visual aids and quantifiable metrics to illustrate the impact of technical depth on the project and the progress made in reductions. You can go with success stories. Share example of improvements and efficiencies gained from the previous technical depth reductions or the effort that you have put. What benefits you have got from there. Similarly, you can organize stakeholders meeting. Maybe once in a month, once in a quarter, whatever suits best for you, you can contact them, bring them under one roof, and you do it in a proper cadence. Don't just do it randomly, so that it will be not something surprise or complex for them. right? So hold regular meetings with stakeholders to discuss technical debt management strategies, progress, and adjustment to plan based on evolving project needs and priorities. And educational session, organizations to educate stakeholders on the concept of technical debt, its cause and the long-term benefits of its reduction, fostering a shared understanding and commitment, and also mentions that how you need their support, how you need their collaboration. Typically, when organizations goes into agile, when we go for a transformation, there are some sessions we go with stakeholders, because this technical depth should not be surprised after 4th sprint or 5th sprint. They should be aware from the very beginning, and this kind of expectation that they need to involve, or the team will be dedicated some time on every iteration, should be accepted from the very beginning. If you do so, it will be make your life more easy to run it. Now, many organizations, when they think about these terms, technical debt, refactors, many people, they think these are just agile terms, these are just agile jargons. Nowadays, agile is become a tool for, it's become a jazzy word, right? Everyone is talking about agile, and many people, they says, okay, agile is not successful for us. Why? Because they think only using the daily stand-up and events and Scrum is agile. But when we talk about agile, it's not talking about any framework, it's talking about those practices, right? And this is something, what happen is, if you are familiar with waterfall, you may not have that small feedback boxes, and you may get after a UAT session, or sometimes you realize at the end of 1 year there are so many bug fixes comes up, and you go for 3 months for doing that, right? That's bring up the project timeline slippage, additional cost. We want to avoid that by applying this. So let's quickly try to find out creating a culture of this continuous improvement. What I'm talking about, it's not only just the practice you can apply, that's a culture that you need to bring in. Advocacy of improvement culture, emphasize the importance of fostering a culture that values and prioritize regular incremental improvements in both code and development process. And this cultural shift is fundamental to not just managing but thriving technical debt. So what are the best practice for fostering this culture? Regular refactoring. Encourage the practice of regular scheduled refactoring session as a part of the development cycle, making code improvement an ongoing task rather than an afterthought. Learning and adoptions. Promote a learning environment where team members are encouraged to share insights, learn from mistakes, and continuously seek ways to optimize workflows and code base. Shared responsibility. Highlight the importance of viewing technical debt management as a collective responsibility of the entire team, including developers, quality assurance team, or managers and stakeholders. So I'll say quality assurance engineers, because we will not be saying quality assurance is a different team. Open communication. Foster open channels of communication where team members can discuss potential issues, suggest improvements, and collaboratively decide on priorities for technical debt reduction. Recognitions and rewards. Implement recognitions and reward system for identifying and successfully reducing technical debt, reinforcing the value placed on maintaining a healthy code base. Rewards and recognition, it's little controversial topics. What you do, how you should do. If you want to know more, there is a different video in our channel we have created, which is kind of a 1-hour video only about rewards and recognitions and your strategy. You can go for that. That's a very important area, how you can balance that. Sometimes it can backfire as well for your team's improvement in agile area. Continuous education is one of them. Offer ongoing educations and training opportunities on best practices in coding, new technologies, and strategies for effective technical debt management. So we talked about few theories. Let's try to see some data, how we can bring it up. We'll take a fictitious name, LinkedIn's linked out initiatives overview. And in this example, the key is how the data is capturing, measuring, making the strategy and applying it and the outcomes. So over here, identification and categorization of technical debt, refactoring as a code strategy, execution of the linked out initiatives, results and impact, and lesson learned. So over here, we will be just showing some data, how a company can take some decisions. Now in your organizations, the decisions may be different, the data may be different, but this is just for an example. So I will talk about the scenario. LinkedIn recognized the challenges posed by accumulating technical debt launch and internal initiated dubbed linked out, aimed at aggressively identifying, categorizing and addressing technical debt across its platform. So the objective is, the primary goal was to improve system performance or enhance the scalability and increase developer productivity by systematically reducing technical debt. So their initiative was launched on 2018 Q1, and based on their identifications, when they tried to measure some, they found 500 initial audit identified. Over total 500 instances were identified, and they tried to did a categorization. Based on that, they found, okay, out of that 40% is code maintainability, 30% related to performance bottleneck, 20% related to outdated documentations, and 10% is security vulnerabilities. So they realized, okay, let's take a process to fix that. So LinkedIn engineers began by conducting a comprehensive audit of their system to identify areas that burdened by the technical debt. They looked into their legacy code, their outdated documentations, and inefficient process that hindered the development. And they make some categories based on that, and these are the typical 3 categories they have identified: performance area, security vulnerabilities, and the code maintainability issues. And as an outcome, they identified these 200 instance of duplicate code, 150 instance of deprecated library uses, 100 instance of incomplete documentation, and 50 security vulnerabilities in code base. I'm just talking about, these are the example data. So the next steps, they need to prioritize, because they cannot work on all of them together, and they realize that we cannot stop the feature development as well. So what they did, they first tried to do the prioritization. So in that first prioritization, they identified and categorized those technical debt items based on criteria such as user impact or security risk and the potential for improving developers' productivity. They found the high priority item. There are 50 security vulnerabilities they want to resolve and 100 performance bottlenecks. And they found there are 200 instances of duplicate code. They are putting it to a medium, and 150 deprecated libraries they will be looking into. And the low priority is 200 instances of incomplete documentations. So what they say is, okay, let's go for a planning. So when they are planning, the cross-functional teams, because the nature of these debts comes up, it cannot be possible for one team to work on that. They may not have the all skill sets to work on that. So they may discuss with the cross-functional teams, including engineers, product management, quality assurance. They collaborated to develop a strategic plan for addressing the high priority technical debt, ensuring alignment with the business goal and product roadmaps, which will be for Q2 the same year, strategic planning session. And they says in the next quarter we may go for a 5 sprint, and in this 5 sprint they have done a capacity allocations like this. So the high priority, they have says, okay, in this one we will be taking 25 high priority bugs, optimize 50 performance bottlenecks, and refactor 100 instance of duplicate code. This is they can go for few more sprint, because over here they may have you'll think about in this particular area. I will just draw a line. They may go for to refine and plan for next 5 iterations that they can go for. Now we had 50 out of that right over here. They are just looking for 25 over here. The goal over here is how they can do a capacity allocations based on different sprint. The numbers you can match it based on your need, your team size, and their capabilities. So as you can see, we have reduced down the feature development much more lower in every sprint, and then once we are coming to the sprint 5, we are completed almost what we have planned. So that's where you will be doing. This is where it will bring up the collaboration. So collaborations and knowledge sharing will increase. Engineer across different teams, they shared best practices and solutions for common technical depth challenges, fostering a culture of continuous learning and improvement. So what's the result and impact? System performance, right? The initiative led to measurable improvement in system performance and reliability, with significant reductions in downtime and latency, 30% reduction in page load times and 20% decrease in system downtime. Developer productivity: by removing obstacles that impeded the development workflows, the initiative boosted developers' productivity, enabling faster delivery of new features and improvement. So over here we can see 25% increase in feature development speed and scalability and maintenance. The reductions of technical depth enhance the scalability of LinkedIn's platform, making it easier for maintain and evolve over time. So 50% reductions in bug fix time. The impact was profound. A 30% reduction in page load times and a 20% decrease in system downtime that marked improvement system performance. And equally, developers' productivity surged with a notable increase in feature development speed and reduced their bug fix time. Right? So what we learned from this example: proactive management. One of the key takeaways from that linked out initiative was the importance of proactive technical depth management and the need of regular audits and assessment. Cross-functional collaborations. The success of the initiative underscored the value of collaboration across different functional areas and highlighting managing technical depth. This is shared responsibility and balancing act. Over here, we demonstrate the necessity of balancing feature development with technical depth reductions, ensuring that neither is neglected at the expense of others. And you will be making some benefits for future, like post initiatives, ongoing quarterly audits you have planned, and technical depth day. You define that we will be going for certain days, that is our technical depth day. Establish a recurring technical depth day for cross-team knowledge sharing. So that's all that I wanted to cover over here. So we came into our conclusion sides. I will not be explaining what is written. This is, if you want to practice few of the suggestions or guidance, you can pause it here and go for it. I believe you got some learning from these sessions. If you got it, I will request you to subscribe our channel or encourage us. Subscribing will not cost you anything, but that gives me motivations to create videos like this. If you found there is some improvements I need to make, give your feedback in the comment section as well. I'll see you in our next video, where I'm planning to work on something, how to resolve conflict, or what are the different aspect of product management, and we will also talk about some other areas related to this context. We'll see you in next video. Till that time, have a wonderful day. Bye-bye.